Hey guys, welcome to my YouTube channel. My name is Powder. Kindly subscribe, share, and like. I'm here to share with you majorly two things, and that's the history of computer generation and the evolution of Intel architecture. So, beginning with the computer generation. Computer generation simply refers to the distinguished varying technologies in hardware and software of a computer system. The computer generation include the first generation, second generation, third generation, up to the later generation. So beginning with the first generation, under this generation, vacuum tubes were used for digitological operations and the memory. The most famous computer under this generation is called the IAS computer, designed by John von Neumann and his colleagues, and it was designed in 1946 at the Princeton Institute for Advanced Studies. The IS computer consists of a main memory, arithmetic and logical unit, and this is capable of operating on binary data, basically for adding, subtracting, multiplying, and division operations. It consists of a control unit which interprets the instructions in memory and causes them to be executed, and it consists of the input-output equipment operated by the control units. So the memory of the IS computer consists of 4096 storage locations called words of 40 binary digits each. Both data and instructions are stored here in the memory. Numbers are represented in binary and instructions are binary codes. So the control unit operates the IS computer by fetching instructions from memory and executing them one at a time. Both control units and arithmetic logic units contain storage locations. For example, it consists of memory buffer register, which contains what to be stored in the memory or used to receive a word from memory or from the input-output unit. It consists of memory address register, which specifies the address in memory of the word to be written from or read into the memory buffer register. It also consists of the instruction register, which contains the 8-bit opcode instruction being executed. So it also consists of the instruction buffer register, which is employed to hold temporarily the right hand instruction from a word in memory, and then the program counter, which contains the address of the next instruction is where to be fetched from the memory. It also consists of a accumulator and a multiplier quotient, which is employed to hold temporarily operands, and also arithmetic logic in the operation is. So the IS computers operates by repetitively performing an instruction cycle. The IS computers operates by repetitively performing an instruction cycle. Each instruction cycle consists of two sub-cycles. During the first cycle, the opcode of the next instruction is loaded into instruction register, and the address portion is loaded into the memory address register. This instruction may be taken from from instruction buffer register, or it can be obtained from memory loading a word into memory buffer register and then down to the instruction buffer register, and memory address register. The operations are controlled by electronic circuitry and result into the use of data path. There is only one register that is used to specify the address on memory for a path. I mean for a read or write, and only one register used for source or destination. The IAS computers had 21 instructions which include data transfer. This moves data between memory and arithmetic logic units register, or between two arithmetic logic units registers. The unconditional it had instruction. It also had the unconditional branch Normally the control unit executes instructions in sequence from memory. So this sequence can be changed by a branch instruction, which facilitates repetitive operations. It had the arithmetic operation is performed by the arithmetic logic units and address modify and then the address modify, which permits address to be completed in the arithmetic logic unit and then inserted into instructions stored in memory. So this allows the program considerable addressing flexibility. So that is what I can talk about the first generation. Then the second generation, it's under this generation. The major change in the electronic computer is the replacement of vacuum tubes with the transistor. So unlike the vacuum tube, which requires wires, metal plates, a glass capsule, and a vacuum, the transistor is a solid state device made from silicon. So the transistor idea was invented at Bell Labs in 1947, and by 1950s had launched an electronic revolution. So transistor computers are characterized by larger memory capacity than the vacuum computer, smaller size than the vacuum computer, greater processing performance than the vacuum computers, greater processing performance than the vacuum computers. So it's under this generation that more complex arithmetic and logical units and control units were introduced. The use of high-level programming languages and the provision of system software which the computer were also introduced. So the system software provide the ability to load programs, move data to peripherals like printers and libraries to perform common computation is similar to modern computers. I mean similar to modern operating systems such as Windows 2. So under this generation, there are several differences from the IS computer, and the most important of this is the use of data channels. So it's under this generation where the data channels were introduced. A data channel is simply an independent input or output module with its own processor and instruction set. So a data channel has its own processor and instruction set. In a computer system with data channels, the central processing unit does not execute input or output instructions. Instructions are stored in a main memory to be executed by a special purpose processor in the main data channel itself. The CPU initiates an input or output transfer by sending a control signal to a data channel, instructing it to execute a sequence of instructions in memory. The data channel performs its task independently of the CPU and signals the CPU when the operation is complete. The other new feature under this generation is the multiplexer. The multiplexer is the central termination point for data channels, the central processing unit, and memory. The multiplexer is the central termination point for data channels, the central process unit, and memory. The multiplexer schedules access to the memory from the central processing unit and data channels, allowing these devices to act independently. So that is what I can talk about the second generation. Then coming to the third generation. This generation was developed in 1958 after the manufacturing of newer and more powerful machines becoming difficult in the second generation. So this could be due to increased cost for transistors and so on. So in this generation, technology of integrated circuits was introduced, and since the beginning of digital electronics and the computer industry, there has been persistent and constant trend towards the reduction in size of digital electronic circuits. So this also means that the computers under the third generation are relatively more the computers under the third generation are smaller than those in the second generation. So under this generation, microelectronics were introduced. Microelectronics simply means relatively small electronics. Under this generation, use of gates and memory cells were introduced. A gate refers to a device a gate refers to a device that implements a simple Boolean or logical function. For example, an AND gate with input A and B and output C implements the expression: if A and B are true, then C is also true, and vice versa. So a memory cell is a device that can store 1 byte of data. Under this generation, data storage is provided by memory cells. Data processing is done by the gates. Data movement is provided by the path among the components, basically from memory to memory and memory through gates to memory. And control is provided by the path among components that can carry control signals. It consists of gates, memory cells, and interconnection among these elements. These gates and memory cells are in turn constructed of simple electronic components such as transistors and capacitor. It's under this generation, the two most important members are the IBM SOC 36, 360, and DEC PDP-8. For example, beginning with the IBM 360, it was the first planned family of computers. When I talk of family of computers, I mean, for example, Dell, it's a family computer. HP, it's a family computer, and so on. The family covered the wide range of performance and cost. The models were compatible in the way that a program written for one model should be capable of being executed by another model in the series. So what is different with the computer family is that it's in series. For example, it's in series. For example, these days, for example, what can I say? For example, I can talk of this Techno series. For example, common series. They have the same family but in series, and with only difference in the time it takes to execute. So the difference is in the time it takes to execute. So the characteristics of computer family include similar or identical instruction set, similar or identical operating system, increasing speed, increasing number of inputs or output ports, increasing memory size, and increasing costs. And this increases going downwards. And this increases like going downwards. Yeah. So then the other one is the DEC PDP-8, and this was from Digital Equipment Corporation and occurred in 1964. it was small enough that it could be enough to be placed on top of a lab bench or built into another equipment. It was cheap enough for each lab technician to have. So the PDP-8 bus, called the omnibus, consists of separate signal paths used to carry, control, address and data signals. Because all the system components share a common set of signal paths, their use can be controlled by the CPU. This architecture is highly flexible, allowing modules to be plugged into the bus to create various configurations. So, coming to later generation, there are basically two major important development under this generation, and that is the semiconductor memory and the microprocessors. The semiconductor memory, since 1970, semiconductor memory has gone through generations. For example, from 1 kilobyte to 8 gigabyte on a single chip, and nowadays we also have 16 gigabyte, 32 gigabyte, and so on. So each generation has provided increased storage density accompanied by declining cost per byte and declining access time. Then there's the microprocessors. This was achieved in 1971 when Intel developed its C404 processor, and this was the first chip to contain all the components of a CPU on a single chip. The 4004 processor can add 2 4-bit numbers and can multiply only by repeated addition. I think we all know what repeated addition means. For example, if we were given 2 times 3, for it just adds 2 plus 2 plus 2 3 times to make 6. Then the next major step in the evolution of microprocessor was the introduction of the Intel 8008 in 1972, and this was the 8-bit microprocessor and was almost twice as complex as the 4004 processor. In 1974, the Intel 8080 was introduced, and this was the first general purpose microprocessor, whereas the 4004 and 8008 had been designed for specific applications. The 8080 was designed to be the CPU of a general purpose microcomputer. So the 8008 processor was designed for general purpose microcomputers. So like the 8008, the 8080 is an 8-bit microprocessor also. However, for it, it's very fast, has a richer instruction set, and has a larger addressing capability. So by the end of 1970s, the powerful general purpose 16-bit microprocessor appeared, and one of them was 8086 in 1981. And both Bell Labs and Hewlett Packard developed 32-bit single-chip microprocessor later in 1981. So Intel introduced its own 32-bit microprocessor in 1985, and that was the 8386 processor. So that makes the end of computer generation, the history of computer generation. So going to the evolution of Intel x86 and ARM architecture. These are two examples of a processor family. So the current x86 represent the result of decades of effort on complex instruction set computers. The x86 incorporates the sophisticated design principles once found only on mainframes and supercomputers. The reduced instruction set computer is the another approach to processor design. The ARM is the best design of these based systems. So it is used in a wide variety of embedded systems and is the most powerful one. So the ARM is the most powerful one. Under the reduced instruction set computer and is widely used in a variety of embedded systems. So the evolution of Intel product line include the 8080 processor, which was used in the first personal computer and Altair. the 8086 processor a far more powerful. The second one is the 8086, which is a more powerful 16-bit machine in addition to a wide data path and large registers. So for it supported an instruction cache or quick that prefetches a few instructions before they are executed. And a variety of this processor, the 8088, was used in IBM's first appearance of the x86 architecture. Then the other one is the 80,286 processor. This extension of the 8086 enable addressing the 16 MB memory instead of 1 MB. When I talk of MB, I mean the megabyte. So then the other one is the 80,386 Intel's first, and this was the Intel's first 32-bit machine, and this revealed the complexity and power of mini computers and mainframes introduced just a few years earlier. So this was the first Intel processor to support multitasking, meaning it could run multiple programs at the same time. The other one is the 80,486, and this introduced the use of much more sophisticated and powerful cache technology and sophisticated instruction pipelining. This also offered a built-in math core processor, offering complex math operations from the main CPU. From there, there was development of Pentium. So with Pentium, Intel introduced the use of superscalar techniques, which allow multiple instructions to execute in parallel. Then the other one is the Pentium Pro. So this continued the move into superscalar organization, which began with the Pentium, data flow analysis and speculative execution. Then the Pentium 2, this incorporated Intel MMX technology, which is designed specifically to process video, audio, and graphic data efficiently. And then the Pentium 3. So the Pentium 3 incorporates additional floating point instructions. The streaming SIMD extension instruction set extension added 17 instructions designed to be performed on multiple data projects. So typical applications are digital signal processing and graphical processing under DC under this Intel. Then another one is the Pentium 4, which includes additional floating point and other enhancements for multimedia. We went to Core and then the Core. So the Core is the first Intel x86 microprocessor with a dual core, referring to the implementation of two cores on a single chip. Then the Core 2, this extends the core architecture to 64 bits. So the Core 2 extends the architecture to 64 bits. The Core 2 quad provides 4 cores on a single chip, and the more recent Core add up to 10 cores per chip. An important addition to the architecture was the advanced vector extension instruction set that provided a set of 200